fuel cell offers several advantages, include high energy efficiency, low emission, quiet operation, and the potential for using a variety of fuel. They have application in various sectors, including transportation, such as hydrogen-powered car, stationary power generation, for homes, business, and remote location, and portable device. It's important to note that there are different types of the fuel cell, each with their own characteristic, operation, condition, and application. The most common type of proton exchange membrane fuel cell, solid oxide fuel cell, molten carbonate fuel cell, and alkaline fuel cell.
Fuel cell is an electrochemical device that uses a reaction with an oxidizing agent, usually oxygen from the air, to transform the chemical energy from a fuel into electricity. High energy efficiency and minimal environmental effect are features of this particular clean energy system. Because of there is no need for combustion, fuel cells are very efficient at converting the energy contained in the fuel into electricity. When compared to conventional combustion-based system, they are more efficient at converting energy. Additionally, since water is the only consequence of the electrochemical reaction, fuel cells emit every little pollution.
There are several materials that are used to make this battery. The first material is anode. The anode is the negative electrode in a battery and typically consists of a material that can store and release ions during the battery's operation. The second material is cathode. The cathode is the positive electrode in a battery and is responsible for receiving and storing ions during the charging process. The third material is electrolyte. The electrolyte is a substance that allows movement of ions between anode and cathode while maintaining electrical neutrality.
The fourth material is the separator, which is also a porous membrane that physically separates the anode and cathode and the battery to prevent direct contact while allowing the passage of ions. It is usually made of materials such as polyethylene or polypropylene, and the last material is the current collector, used to collect and distribute the electric current between the battery electrodes and the external circuit. They are often made of metal such as copper or aluminum and can be in the form of foil, grids, or other conductive structure.
The catalyst should be present at the anode. Platinum powder can be used as a catalyst. To oxidize, the catalyst is utilized. Fuel made of hydrogen. As hydrogen gas changes, ions and electrons are produced. The electrolyte serves as a conduit for the ion journey to the cathode. When they get at the cathode, they join with the cathode and begin to react with the oxidant, creating water. The passage of the ion results in generation of electricity.
Reaction occurs in fuel cell. Hydrogen fuel cell is a spontaneous redox reaction to produce current that can do works. The net reaction for this reaction is exothermic reaction. Cathode half reaction is where 1 mole of hydrogen gas react with half mole of oxygen gas to produce 1 mole of water, where the energy required in converting 1 mole of reactant to 1 mole of product is negative 229 kilojoule per mole. Anode half reaction is 1 mole of hydrogen gas produce 2 mole of H plus and 2 electron. The E naught cell for this reaction is 0.00 volt. The overall reaction is 1 mole of oxygen reacts with 4 electron and 4 mole of hydrogen ion to produce 2 mole of water. E node for this overall reaction is 1.23 volt. As you can see, the overall potential value becomes positive after the two half cell potential for the electrochemical reaction being combined.
Methanol fuel cell, the power source for this cell comes from renewable sources, which is methanol. It is a liquid fuel that can produce through fermentation. The electrochemical reactions below occurs in this direct methanol fuel cell. The anode reaction is methanol plus water produce carbon dioxide plus 6 hydrogen ion plus 6 electron. The cathode reaction 3/2 oxygen plus 6 hydrogen ion plus 6 electron produce 3 water. Last is cell reaction, methanol plus 3/2 oxygen produce carbon dioxide plus 2 water.
Fuel cells cannot be recharged in the same way as batteries. Fuel cells are electrochemical devices that convert the chemical energy of a fuel, such as hydrogen, into electrical energy through an oxidation-reduction reaction. Unlike batteries, which store electrical energy, fuel cells require a constant supply of fuel and oxidation agent to sustain the electrochemical reaction. This fundamental difference is why fuel cells cannot be recharged in the same way as batteries. To replenish the fuel in a fuel cell, you need to refill the hydrogen source. This usually involves refilling the fuel reservoir or connecting to a hydrogen supply.
Advantages for fuel cell. First, renewable and easily accessible. This is particularly sustainable and limitless form of energy. Second is well competent compared to other energy sources. This is for fuel efficiently allows a greater productivity capacity per kilogram of fuel. Next is more durable and energy efficient in comparison to fuel cell. The hydrogen fuel cell technique delivers a robust, high efficiently source of power.
Next, minimize carbon residues. This is because hydrogen fuel cell emit almost no greenhouse gases, implying a negligible carbon footprint when in operation. Minimal sound pollution. Hydrogen fuel cells do not generate excessive noise like some other alternative power sources, including wind energy. Ability to adapt. Hydrogen fuel cell would be equipped to provide power for various stationary and consumers devices whenever technology advances.
Fuel cells have several disadvantages, some of which include: first, high cost. Fuel cells are currently expensive to produce, which make them less competitive in terms of cost compared to other energy sources. Second, limited fuel availability. Fuel cells require specific fuel such as hydrogen, which is widely available. This limits their application in areas where these fuels are not easily accessible.
Next is durability issue. Fuel cells have durability issue, especially with their catalyst and membrane, which can become contaminated and degrade over time. This can reduce their efficiency and lifespan. Besides that, safety concern. Hydrogen fuel cells have safety concern due to the flammability and explosion risk of hydrogen gas.
In summary, a promising technology, fuel cells have a chance to be crucial as the economy transitions away from fossil fuels. More research and development is needed to solve these technical problems. Fuel cells are a far less developed technology than batteries or combustion engines, despite the fact that they have been around for a very long period. This indicates that fuel cells will probably keep getting better.